Hi guys. So we will solve this problem. So the question here is, you are the operations manager for an airline and you are considering a higher fare level for passengers in aisle seats. How many randomly selected air passengers must you survey? Assume that you want to be 99% confident that the sample percentage is within 2.5 percentage points of the true population percentage. Assume that nothing is known about percentage of passengers who prefer aisle seats. Okay, so to solve this problem, so I would like to remind you the formula for the margin of error. Okay, so the margin of error E equals G sub alpha over 2 radical P hat Q hat divided by N, right? So this is the margin of error, and we use this formula to calculate the margin of error. So now we are going to find out the sample size n. Okay, so we have to solve n from this equation. So how can you do that? So u squared on both sides. So squaring, you will get e square equals g alpha over 2 square, and when you square on both sides, this radical sign will be gone, right? So you'll have a p hat q hat over n. So here you are going to solve for n, okay? So you multiply both sides by n. So if you multiply both sides by n, then you can cross them, right? You can cancel n on the top and on the bottom. So you will have n times e square equals g sub alpha over 2 square times p hat q hat, right? So you divide both sides by e square, okay? So if you divide both sides by e square, so you'll have e square on the bottom here, and this e square and the bottom e square, you can cancel them, right? And so you will end up with what? So you'll have n equals g alpha over 2 square times p hat times q hat over e square, right? Now this is the formula to find the sample size, right? So so you need, if you know the value of g alpha over 2, p hat, q hat, and the margin of error, then you can find the sample size, okay? So sometimes you may not know about p hat and q hat. In that case, we generally consider p hat equals q hat equals to 0.5, and so if you don't know about the estimate of p hat, we generally consider p hat equals q hat equal to 0.5, and if you plug in the value of p hat and q hat here, so it's going to give you n equals g alpha over 2 times 0.5 times 0.5, and you divide by this over what? Margin of error, e square. right? So, but you know when you multiply 0.5 with 0.5, you will get 0.25, right? So 0.5 multiplied by 0.5, you will have 0.25, okay? So this is the formula to find the sample size if the estimate p hat is unknown, okay? So now let's apply this. So let's use this formula, okay? So what you need here is you need z alpha over 2 and you need the margin of error, right? So assume that nothing is known about the percentage of passengers. So you don't know the p hat. So in that case, you have to use this formula, okay? So this one. You have to use this formula, right? So what we have, we know the margin of error, right? The margin of error E is, I think like somewhere in the problem. Okay, here. Assume that you want to be 99% confident that the sample percentage is within 2.5 percentage points of the, okay, this is the margin of error, okay guys? Okay. So now, what is the value of E? So the value of E here is 2.5%, right? Which is 0.025. So next, we have to find out Z alpha over 2. And you see here the confidence level is 99%, right? So that means, you know, the confidence level is the probability 1 minus alpha. So this is 99% is 0.99. So from here, if you solve for alpha, so this is 1 minus 0.99 is, I think like this is 0.01. But you need alpha over 2, so you divide both sides by 2. So alpha over 2 is, if you divide 0.01 by 2, then you will have it 0.005, right? So you need to figure out the value of G 0.005. Okay, so if you know the value of this, you can plug in here, and you already knew the margin of error, right? And you can just do the, you can just calculate the value of n. Okay, so now what is this? So this is exactly, if you have a so you need this value, right? So if you have a standard normal curve, let's say this is your standard normal curve, right? This is your standard normal curve. So this is a Z score, right? So this Z.005, this is the Z score, right? Z.005, whose area to the right, so this area, so whose area to the right, so this area, right, this area is 0.005, okay? And to find the value of this Z.005, you need the area to the left, okay? And you guys know the area under the density curve, the total area under the density curve is 1. If you subtract 0.005 from 1, so this is 1 minus 0.005, so which is, I think like this is 0.995, this area, right? So the area to the left of this is 0.995. Then you can use the calculator to find the Z value. So you just like, I am using TI-84 Plus. So you have to press second, then you have to press VARS and go to number 3. and you have to fill out area equals to 0.995, and then you hit enter until you get the value of z, right? So now I got the value of z is 2.58. So I round up to 2 decimal places. So this value is 2.58. Okay. Now I know the margin of error, which is 0.025, right? And then for 99% confidence, I also know the value of z alpha over 2, right? So the value of z alpha over 2 is 0.005, which is 2.58, right? And now you plug in these values in this formula, okay? The bottom formula, so this one. So n equals z alpha over 2, so 2.58. I just plug in the value of z alpha over 2 and they square that times 0.25 over, I have a e square and the margin of error is this, so 0.025 square, right? And then when you use the calculator to compute the value here, you will end up with 2663. Okay, so I round up the nearest integer. Okay, I round up the nearest integer. Okay, nearest integer. So this is the sample size. So if we know nothing about the percentage of passengers who prefer aisle seats, so we will select 2,663 passengers in our survey. Okay, so this is the answer for part A. Okay, so for the part B, we have this problem. So let me erase this. So for part B, so the part B is assume that a prior survey suggests that about 32% of air passengers prefer and aisle seats. Okay, now look here. So in part A, we did know nothing about the sample estimate P hat, right? So we did know nothing about P hat, but here we have a P hat which is 32%, right? And which is 0.32, and you know the formula is n equals z alpha over 2 square and p hat q hat over, right, margin of error square. This is the formula. So we know the value of p hat, and you guys know q hat is 1 minus p hat which is 1 minus 0.32, which is 0.68, right? And the margin of error is exactly same, 2.5 percentage, right? So 2.5%, and which is 0.025. So now we have every information in our hand, right? So we have a p hat, we have a q hat, we have a margin of error E. So you just like a plug in the values here. So it will give me, so Z alpha over 2, I already calculated that. This is 2.58, right? So let me write down here, Z alpha over 2 is Z 0.005 is 2.58, and you plug in here 2.58 square, and the P hat is 0.32, and the Q hat is 0.68 over E square is 0.025 square. Okay, so now if we compute this, if you calculate this using a calculator, and if you round up the nearest integer, then you will I think like you will have okay, so this will give something like this. It is 2317.4922, something like that. And if you round up to the nearest integer, so it will give me 2318. Okay, so if we know this p hat, right, then we will select 2318 passengers in our survey. Okay, thank you guys.